Internet of Things. IoT is a network of physical object things that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the Internet. The most common sensors in IoT are the same sensors that can be found in our smartphones. For example, microphone, compass, NFC or RFID sensor, capacitive touch sensor or screen, accelerometer, GPS, gyroscope, fingerprint, light or image or video sensor or camera. In 1970, the actual idea of connected devices was proposed. In 1990, John Romke created a toaster which could be turned on and off over the Internet. In 1995, Siemens introduced the first cellular module built for machine-to-machine. In 1999, the term Internet of Things was used by Kevin Ashton during his work at P&G, which became widely accepted. In 2004, the term was mentioned in a famous publication like The Guardian, Boston Globe, and Scientific American. In 2005, UN's International Telecommunication Union published its first report on this topic. In 2008, the Internet of Things was born. In 2010, sensor support was added to Android. In 2011, Gartner, the market research company, included the Internet of Things technology in their research.
Number 1. Big analog data. Analog data represents the natural and physical world and is everywhere, or in other words, is part of everything. Light, sound, temperature, voltage, radio signals, moisture, vibration, velocity, wind, motion, video, acceleration, particulates, magnetism, current, pressure, time, and location. Number 2. Perpetual connectivity. The IoT is always connected, always on, and that perpetual connectivity to products and users affords 3 key benefits. Number 1. Monitor. Continuous monitoring, which provides ongoing and real-time knowledge of the condition and usage of a product or user in a market or industrial setting. Number 2. Maintain. Due to continual monitoring, one can now push upgrades, fixes, patches, and management as needed. Number 3. Motivate. Constant and ongoing connection to consumers or workers gives our organizations a way to compel or motivate others to take some action, purchase a product. Number 3. Really real-time. The definition of real-time differs from people who don't understand the IoT than from people who do. Real-time actually begins back at the sensor or the moment the data is acquired. Real-time for the IoT does not begin when the data hits a network switch or computer system. By then, it's too old. Number 4. The spectrum of insight. The spectrum of insight derived from the IoT data relates to its place in a 5-phase data flow: real-time, in motion, early life, at rest, and archive. Number 5. Immediacy versus depth. With today's traditional computer and IoT solutions, there's a trade-off between speed and depth. That is, one can get immediate time to insight on a rudimentary analytics such as temperature comparison or fast Fourier transform to determine if rotating wheels on a tram will cause a life-threatening accident. Immediate time to insight is crucial here. Number 6. Shift left. Consider the mutually exclusive objective of deriving both immediate and deep insight. As discussed in number 5, it's really hard to get both today. However, engineers are good at resolving conflicting objectives and getting both. James Collins has referred this phenomenon as the genius of and the end. Number 7. The next V. Big data is commonly characterized by the famous V's: volume, velocity, variety, and value. I propose a 5th V: visibility. When the data is collected, data scientists around the world should be able to see and work with it as needed. Visibility refers to the benefit afforded by not having to transfer large amounts of data to remote people, or locations.
Number 1, meeting customer expectations. Number 2, easing security concerns. Number 3, keeping IoT hardware updated. Number 4, overcoming connectivity issue. Number 5, waiting for government regulation. Number 1, mobile phones used for a variety of purposes, such as keeping in touch with family members, for conducting business, and in order to have access to a telephone in the event of an emergency. Number 2, smart TV uses for home network, provide streaming video and services on your TV. Number 3, smart outlets to use smart plug. You plug it into a standard wall outlet and follow some simple setup procedures such as installing a mobile app and connecting the device to your home Wi-Fi. Number 4, parking sensors are the proximity sensor, which is used to help the vehicle driver in identifying near vehicles while parking. These sensors at the back bumper of the vehicle, and it is also called a driver assistance system. Number 5, inventory trackers offers constant visibility into the inventory by providing real-time information fetched by RFID tags. Number 6, cashless payments can provide huge revenue boost to companies and teletext, which makes RFID-enabled payment solutions, conferences, and other large events.
Advantages. First is communication. IoT encourages the communication between devices, also famously known as machine-to-machine communication. Next is automation and control. Due to physical objects getting connected and controlled digitally and centrally with wireless infrastructure, there is a large amount of automation and control in the workings. Next is information. It is obvious that having more information helps better decisions. Monitor. The second most obvious advantage of IoT is monitoring. Knowing the exact quantity of supplies or the air quality in your home can further provide more information that could not have previously been collected easily. Time. As hinted in the previous examples, the amount of time saved because of IoT could be quite large. And in today's modern life, we could use more time. Money. The biggest advantage of IoT is saving money. If the price of the tagging and monitoring equipment is less than the amount of money saved, then the Internet of Things will be very widely adopted. Next is better quality of life. All the applications of this technology culminate in increased comfort, convenience, and better management, thereby improving the quality of life. For disadvantages, compatibility. Currently, there is no international standard of compatibility for the tagging and monitoring equipment. I believe this disadvantage is the most easy to overcome. The manufacturing companies of this equipment just need to agree to a standard, such as Bluetooth and USB. This is nothing new or innovative needed. Next is complexity. As with all complex systems, there are more opportunities of failure. With the Internet of Things, failures could skyrocket. Privacy or security. With all of this IoT data being transmitted, the risk of losing privacy increases. Last is safety. Imagine if a notorious hacker changes your prescription, or if a store automatically ships you an equivalent product that you are allergic to, or a flavor that you do not like, or a product that is already expired. As a result, safety is ultimately in the hands of the consumer to verify any and all automation.
Critic. The IoT provides a platform that creates opportunities for people to connect these devices and control them with big data technology, which in return will promote efficiency and performance.
Just like in healthcare industry, by helping doctors gain faster access to patients' data.
Wearable internet-connected sensor devices that track a patient's heart rate, pulse, or even blood pressure are increasingly affordable, compact, and accurate.
While there is still some debate over how to safely collect, transmit, and use this data, wearables are one of the most promising IoT applications in healthcare.